Hello, pre-calc. So let's continue our lessons on limits. This lesson is about the three conditions for continuity. So there's three things that have to happen. So the first one that I would like to talk about is f of a must be defined. Okay, the second one, the limit as x approaches a for the function must exist. And then the last one, f of a must equal limit as x approaches a of f of x. So basically, you have to check for 1 and 2, and then these must be equal. Okay, so I'm actually going to take you through the steps. What we're getting ready to do right now, all the steps will also be on your worksheet when you get handed that today. So continuous just means that the graph has no breaks. Okay, so here we go. So we're basically going to graph it. We're going to find the f of a value, find our limit, and then write whether or not they are equal, and then say if the function is continuous or discontinuous. And of course, we're always going to go back to these three definitions. So let's go look at the first one. So the first one we're going to do is a piecewise. So we have to graph this first. For this one, I actually want to start in the middle because I know you guys struggle still a little bit with piecewise. This is a continuous function. Not continuous, I'm sorry, constant function. And if I was to ask you to graph this one, you would just go up to 2 and put a straight line. But here's the thing, I only want it for when x equals 1. So basically I just want it to be right here. I don't want it to be greater than, and I don't want it to be less than. I only want it to be for when x is 1. So therefore, I will have just a dot at when x equals 1. Okay, the second one that I would like to do is actually the bottom one right here. Okay, because I think you guys probably have this one down pretty good. So I know some of you guys still like making your charts so that you can visually see where you're starting. So if I was to plug 1 into the function, what would we get? Yep, a -1. So that means we are going to have an open circle because it's not going to be equal to it. Then from here, you can keep going in the positive direction. So that means my next one would be a 2. And you can plug that in and get a -3. Or I know some of you guys like to go use your slope of a -2. So therefore, we would just go backwards 2. And then we would draw our line. Okay, and then let's do this last one right here. Okay, so we can do the same thing. We can go make our chart. So we're going to start with the 1, and when I plug 1 in, I get a -1, and we're still going to have an open circle. So we're actually restarting right here. But this is a quadratic, so I don't want to use my slope. So if you want to, we can just keep plugging in points. We can use a 0, which would give us a -2. And then when I plug in a -1, we can clearly see that we are starting to repeat. Because this quadratic actually just shifts the parent function down 2. So then we're back here, and then if you want to, you can just finish with your pattern. So that was 1, and then we go 2, 3, 4, 5, 6, 7, 8, 9. And then graph your quadratic. Okay, so part A is done. Part A is to just graph the function. So then let's look at the rest of the parts. So part B wanted you to find what f of A was. So this is part B. So here's what A is. So when I plug 1 in, what is the actual value that we get? So if you're looking at the graph, when f is 1, or f of A, what we want it to find of 1, that just means that we are looking here. And we want the actual value. The actual value is 2. Okay, that's what B was asking. C was asking you for the limit as x approaches 1. So remember, the limit is when you're coming from this side and this side, am I going to approach the same exact value? So yeah, as I'm coming up from the right, I approach here. As I'm coming down a little bit back up, I'm approaching right here. So my arrows are all going to match up right here at the -1. So that means my limit as x approaches 1 is a -1. Part D was wanting you to state whether or not they were equal. So when I plugged in my f of 1, that did not equal my limit as x approaches 1 of f of x. So therefore, the graph is discontinuous. Because f of A did not equal the limit as x approached A for the function. Okay, so we answered all our parts, so we are done. So let's go to example 2. So it looks like on example 2, we are going to have a rational function. So we have to do everything for our rationals. So there's no factoring, there's nothing we can do to this. So that means we're automatically going to have a vertical asymptote. And when we set the bottom equal to 0, we find out that it is x equals 2. So I'm going to come over here and draw my line. When the degree on top is lower than the degree on bottom, that means you have a horizontal asymptote of y equals 0. And then from here, we can just plug in some points for our graph. So if we were to plug in a 3, we would get a 3. Plug in a 4, we would get 1.5. Plug in, that was a 4, so a 5 would give us a 1. So it looks like it's going to go here, get close but not touch. So we'll go backwards. If we plug in a 1, we would get a -3. Plug in 0, we would get the -1/2. Plug in -1, we get a -1. So it looks like it's gonna swoop here and here. So there is our rational graph. So let's go answer our parts. So graphing was part A. Part B was find the actual value at 2. Well, since we're looking for when x is 2 and x2 is our vertical isotope, it looks like it will be undefined. Okay. C is for us to find the limit as x approaches 2 for the function. Well, the limit does not exist because we are approaching the vertical isotope as well. Part D, well, so we have f of 2 will not equal the limit as x approaches 2 for the function. Okay, because remember we said that f of a must be defined, so we're already wrong here. We also said that the limit as x approaches a of the function must exist. Well, this is wrong here. So therefore, it basically failed. So for E, this would be discontinuous. Okay, because it failed A being defined, or f of a being defined, and it also failed that the function must exist. So, all right, f of a does not equal limit as x approaches 2 of f of x. Okay, and then I also made notations up here that these failed the first 2 conditions. Hope this helps you guys.